Do you want me to say?
Yeah, go ahead.
Okay, my name is John Kongdew. John, John.
Yeah, that doesn't matter to me. If you on Zoom, it'd be
Yeah,
okay.
because
It,
I don't see the lesson. Listen, Lessson. Listen, I don't see anything
what do you mean you don't see?
because actually I don't see your teaching.
I think he
It's
took it off.
blind. Yeah, it's blind. My computer is blind. All.
Oh, that's what I cannot have.
Yeah,
Oh, now we see your beautiful face.
I can't see your face, teacher. I want to see your face.
I think you got to work on your own settings.
Yeah,
Yeah, I can see him. I see. You just got to make it to where you can see everybody. It's
very
on
good.
your end though.
Yeah, it belongs to teacher to adjustment. Set it belong to teacher.
Yeah, if you want to see him the whole time, right click on him and click on pin, and that will keep his picture in the center for you.
I didn't see him here.
He should be near the front of the list there. Once you find him, you just right click on pin, and then his picture is going to be in the center, and it's going to be in front of everybody else's.
I have what is called the C. No, not his name here. Teacher, not. I don't have his name here. For sure, I don't have his name.
He's there somewhere.
You got it? Yeah. Now lesson is coming.
Okay, now you can see.
Yeah, I see now. Thank you so much. This is fundamental. Yeah, I see now.
Okay, now we try to get through
Now I see everything.
the DC,
Very secret. Yeah.
parallel circuit. Okay, so quickly get it done. Okay.
Okay.
Man. You know, last time we already talking about the parallel circuit that we be telling you on the voltage across a resistor in parallel will be the same. The current will be different between R1, R2, R3, and so on. Okay? And the total current will be equal I1 plus I2 plus I3, okay, for each branch. And this is the calculation, okay, for resistor in parallel. Basically, that you want to combine all of the resistor in parallel into only one resistor. Okay, so on this one here, okay, they want to know what the total resistance. So you can see these are one or two parallel. You have to combine to one resistor. And also this one are 3 or 4 combined to another one. And you will be get two resistor in the parallel. Okay, to calculate the equivalent resistor. So if you get 1, 2, 3, 4, then you have to using the formula. That is the formula here. Okay.
Okay.
Just a minute.
R T equal 1.
That means you get R1, R2, R3 in parallel. Then you have to combine it to one resistor. R total will be equal 1 over R1 plus 1 over R2 plus R1 over Rn, no matter how many more you get in parallel. Okay? And if you get only 2 resistors in parallel, you using this formula. R total equal R1 times R2 divide R1 plus R2. Okay? This formula apply for more than 2 resistors in parallel. And this formula here, only 2 resistors in parallel. Okay? For example, that one, you get R1, R2 parallel. So you can using R1 times R2 divide R1 plus R2. Okay? And now, in the voltage, in the series resistance, you get the voltage divider. Okay? And now in the parallel, you get what they call a current divider. That means if you get a total current going to that point here, one go I1, one go R2, then you're using this formula. I1 equal I total times R2 divide R1 plus R2. And if you're going to calculate the I2, then they will be equal I total times R1 divide R1 plus R2. Now, this is the example, okay? We already given solution, so I just try to explain to you, okay?
If you for secret to down turbine the following quality. ART IT power delivered by the water source.
Okay, now, so you still get the E here, plus, minus, and U1 are total, okay? And R total, you get R1 and R2 parallel. You're using formula R1 times okay, R1 times R2 divide R1 plus R2. That one is total. Okay.
1.
And now if you're going to calculate the I total,
Yeah.
then the I total equals E divide
R T
R total. Okay.
R.
That's what we already calculate for you. R total here. And you want to get the current I total. Okay. That means E divide R total. And if you want to calculate the power, okay, total power will be equal E times total IT. Okay, and now if you want to calculate the I joule, that means you want to calculate the I joule here. Then you using the current divider law. That means I joule equal I total time R1 divide R1 plus R joule. If you want to calculate the I1, then you take the I total time R joule divide R1 plus R joule. If you want to calculate the power on R1, you're using formula E square divide R1. If you want power on an R joule, then E square divide R joule. That means you already get the formula. And now,
Professor,
yes,
I'm a little confused with that previous page because you got two different formulas up there for the same thing. So under solution, it says RT is R1 times R2 divided by R2 times R2. Yet on the other side, you wrote the RT is equal to R1 times R2 divided by R1 plus R2. So which one is the correct formula?
okay, now you're talking about I joule, right?
And then on A.
I joule equal I total.
Mr. Pham,
Let's talk about resistance.
what he's talking about is on where you got solution and then you got the letter A, you got R2 times R2. I think what you meant to put was R1 plus R2. Look at letter A under solution.
For the resistance total.
You mean that you can add the bottom one and multiply up there and divide it. We equal 1.
Okay, now, is it IT total current time R1?
That's not what he's talking about.
No,
He's talking
Professor,
about letter A on the solution.
for the RT equals the resistance
yes.
total, that one is a different formula than what you wrote on the right-hand side.
That formula is wrong.
Okay,
It's a typo. Just
okay.
move on.
R1 time R2. Okay, thank you. R1. Plus
Plus R2.
yeah, thank you.
R1 plus R2.
Okay,
Right,
Yeah.
that's correct.
So,
That's
but
right.
what's the answer? Because my answer, I came out with 6.4 kilo ohms, and you have 1.6.
okay.
Yep.
2 times 8, 16, right?
All right.
Divide 2 plus 8, 10. Is it 1.6?
Yes.
So
That's weird.
answer will be correct. Okay, any wrong on that? Answer here. Okay, now this will be talking about you using the meter to measure the voltage and the current. First thing I talking about, measure the voltage. Okay, so measure the voltage positive. Connect to point B or point A. That means connect this side and the low side meter. will be connected to the ground. Okay, that will measure the voltage. However, when you want to measure the current, then the first thing you have to change this one here. Okay, connect to current this side. Okay, and you connect one side of the resistor. However, you have to let the current go here, go through the meter and go back to the resistor. So that's why you have to break the circuit. Okay, break it out. That is the way how to measure the current. But that never happened at work. That means working in the company, you never measure the current. Why? The thing is, when you want to measure the current, you have to break the circuit. Okay? That's not allowed you to do it. So normally, if they want current, they just try to get the voltage and you divide to the resistor, you get the current.
Professor,
Yeah.
but couldn't you measure the current? Well, this is obviously a battery, but couldn't you measure the current by connecting the meter to the actual pole on the battery and on the opposite side of the wire that's coming off the wire, or like a plug out of a wall? Couldn't you actually put the meter into one side of the plug and put it into the other side of the device without breaking the circuit?
No. How can you not break the circuit? You can let the current go to the meter and go back to the ground.
I agree.
No way. You have to break the circuit.
No, but I was saying if this is a device that actually is plugged into the wall, couldn't you
No.
put the meter between the plug and the outlet? I remember where the plug's coming out of the outlet.
Okay. If you want to connect the other side, okay, go to the, let's see, this is current have to go to here, right? You have to let it go to the meter. And the meter current must be go through the resistor.
Ah, okay.
Okay? So that's why what I'm saying is, you can work in that in the left phone. The thing is, left phone already designed for you to measure the current. However, at work in a company, never measure the current. They not allow you. The thing is, you have to break the circuitry. That cannot be happen. Okay, so basically, this just quickly go through here. We'll be telling you tomorrow. Okay, Mr. Tai will be telling you. Okay, whatever this is a meter, you want to measure voltage DC or measure voltage AC. Okay, either AC and the DC voltage or the current. Okay. And the meter here can be little different from meter at the lab. The thing is, it cost more money. Okay, telling you they can be measure more things than the other in the lab. However, this is an important thing for you to measure the voltage at point C. That means a single point. That means you measure voltage from A or C or D. Then the high side of the meter will be connected to either B or C or D. However, low side of the meter must be connected to the common, to the ground. Okay? If you want to measure the voltage across R2, That means you want to measure the voltage across R2. High side of the meter connect to C. Low side will be connect to D. Okay. Any single point you want to measure, they have to low side of meter have to be common ground. Okay, that's what they're telling you here. UDMM to measure AC voltage, AC current. Only voltage you can get EVRMS. Okay, do not get V peak. You cannot get V peak to peak. Okay, if you want V peak, you get a VRMS and you have to convert it into the V peak. The current, same thing. That will be the IRMS or IAC. Okay. To measure the current either DC or AC, you must break the circuit. This is not practical happen in the company. Okay. So basically, you cannot measure the voltage or current. Measure the current, okay, AC or DC at work. You have to break the circuit. Now this is just a little more detailed, okay. You see that they want to measure the voltage. So basically they have to break the circuit right here. So the current will be go through the meter and then go back to the route. Okay, so that's not allowed. That's what I said at work. Okay, and now today I will be stuck with the electronic. Okay, this is the main thing. Very important thing for you guys, okay? You see this is a sideway. Okay, and basically the voltage from 0 up to the top or 0 to the bottom here, that's what we call V peak. Okay, and voltage from the top to the bottom here, V peak to peak. Okay, and when they start going up, going down, going up again, so that's why you can get one cycle or period. Okay, and this is the time domain. Okay, that means the signal vary with the time. And this one we don't care. The thing I did for radio frequency. Okay, not for the one we have to learn at this time. And basically try to memorize the definition here. Cycle. What is a cycle? One complete occurrence of a repeating wave periodic signal, such as one positive and one negative alternation of the sine wave. That's the one cycle. What is the frequency? The number of cycles of a signal occur in 1 second. What is the period? The time distance between two similar positions on periodic wave. Okay, wavelength and wavelength here just for RF. We don't want to confuse right now.
Professor,
Yeah,
So if I'm reading this correctly, one cycle is actually contains 2 periods.
just a minute. What you mean?
So there's 2 periods in every one cycle, if I'm reading this correctly, correct?
No, from here
One.
to here, one cycle, one complete period. That means one cycle. Okay? The thing is, when they're going up from here to going down, they not repeat yet until they're going up again. They repeat it. That means from here to here, one cycle.
Right, but the period is actually where
From
the
here.
actual sine wave hits the 0 line again, not where it goes negative.
No, one cycle. That means from here they're going up, they're going down. It's not a cycle yet until they're going up again.
Yeah, that I understand. I was asking about the period. So
That's a period.
that is so a cycle and a period is the same thing?
Same thing.
Oh, okay.
Now, this one basically, you guys will be very soon. You have to looking into the oscilloscope. This is a display oscilloscope. Okay, so going up or down, that's for the voltage. Going to the left, to the right, that will be for the period. Okay, that is the time domain. Now, if you're looking on that one, from here, they start from here. They're going up. And when they're going up again right here, so that is a one cycle of one period. Okay? And basically, going up or going down, display for the voltage. You can see how many divisions. 1, 2, 3, 4, 5, 6, 7, 8 divisions. Okay? Now in here, they say in the display 1 volt per division. So if you want the volt peak to peak, can we do calculation? How many divisions? You can count 1, 2, 3, 4, 5, 6. 6 divisions, and each division will be 1 volt. So that's why they call a V peak to peak will be 6 volt, and V peak will be 1, 2, 3 divisions. Each division 1 volt, they will be 3 volt. Okay, 3 volt here
Mr. Pham,
and 3 volt here.
Mr. Pham,
Yeah,
I think some people are trying to join right now.
I didn't see any name here. I don't know they know how to get in or not. If you get in, your guy, the name supposed to be displayed on mine, but I didn't see. That's the problem. Yeah. I don't know what can I do. Okay. If they know how to get into the Zoom, they're supposed to be show me here. Okay. So when you see the signal look like that one display on the oscilloscope, you're able to tell me how many volt peak or how many volt peak to peak. Okay. And now from the left to the right will be for the period if you want to measure. Okay, you can see how many divisions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 division. Okay. 10 division. Okay, now let's see. They say the scope display 1 millisecond per division. So if you want to calculate the period, will be going from here to here. So these are half 1, 2, 3, 4, 5, 6, a half 7. Okay, so 7 times 1 millisecond. That one to get a period is 7 milliseconds. Remember one thing. Can we using the oscilloscope to measure the frequency? The answer will be no. Okay, this is the time domain. Okay, that means they vary with the time. So you cannot measure the frequency. Only you can measure the period. If you want the frequency, you have to using the formula F equal 1 over T. Okay, in order to get the frequency. Again, they give it to you. A definition again, frequency is a number of cycles of a given waveform that occur in 1 second. Okay, when we're working on the left wall, that will be helping you to understand more. And now the next one we're talking about, the diode. Okay, basically you can get the diode. This is a physical. Okay, physical for the diode. One side contain positive, the other side contain negative. Okay, when you get the power, so the electron moving, so the diode will be allow the current flowing. And the symbol for the diode will be look like diode symbol. This is the anode and this is the cathode. And the voltage, okay, of the diode VD equal VAC. That means VA minus VC. And they're telling you the voltage across the diode. Okay, when you see this symbol, and you know this is a diode. Okay, they can make by silicon or they can make by germanium. And one side here will be anode and the other side cathode. And VD, that means the voltage of the diode will be equal the voltage from A to C. That's what we could see here, VA minus VC. Okay. Diode normally permit the electron current flow only in one direction. Okay. So basically the purpose of the diode, they allow only current flowing from A to C, but not from C to A. Okay, only one direction. Now, first thing they're talking about ideal diode. Okay, permit current flow from A naught to the cathode. Diode on. Okay, or forward bias. If you say the diode forward bias, that means they allow the current flowing from A to C. What that means for ideal diode? Ideal diode VD will be equal 0 volt. Okay, that never happened Okay. Reverse bias. That means the diode will be off. Okay. So this is the display in here. You can see. If you say the diode off, that means reverse bias. Then look like they will be open. Current cannot flow it anywhere. And if you say the diode will be on or forward bias, they will be connected from one side to the other side for the current flow. That's a very simple for the diode. First thing, when you look into the symbol, you know this is a diode. Okay? And if the voltage from the anode to the cathode greater than some voltage like 0.7, then the diode will be on. Okay? They will be allowed the current flowing from A to C. If they less 0.7 for silicon diode, then the diode will be off. Off means they open, no current flow.
Professor,
Yeah,
so on the last slide, it said the voltage would be 0 on ideal diode, but you said that never happens. Is that because there's always some resistance in a diode?
no, that's just the ideal. They don't care about that. That means normally VD equal 0.7 volt for silicon diode. That makes
Okay.
by silicon. Or 0.3 volt for germanium. However, they say, okay, if we say the diode is the ideal, then they don't care about the 0.7 or 0.3. They're supposed to be 0. And that never happened, okay?
Okay, got it.
You see that? Second approximation. That means when the diode will be substituted by the battery. Okay? Either, when the diode, they basically, you want to solving the problem. Then you cannot see the diode anymore. You have to put it by 0.7 volt. Okay? For silicon. That's what only we using. Same thing. Reverse bias. That means diode off. They open. Cannot current, cannot flow it. However, forward bias, then the current will be flowing from A to C. Okay, now, first thing, you can get the voltage 10 volt and 1 kilo ohm. And now this is the diode. First thing, if you want to working on a diode, then you have to know the diode on or the diode off. And this diode here will be silicon 0.7 volt. Okay. Now, if you're looking on this circuitry, how do we know the diode will be on or off? That's the first step you have to know. How do we know?
Direction of the diode in the schematic.
Yeah, on this one here. Can you tell me the diode on or the diode off?
The diagram.
Bias or reverse bias?
Symbol.
You have to show that the anode is more positive than the cathode. If that's so, then it's forward bias. Otherwise, it's reverse bias.
Well, it looks like the same picture on the previous slide that said ideal. It doesn't look like a reverse bias or a forward bias according to the picture on the previous screen. So
No,
those
no.
of us who are new, we can only go on that, right?
Okay. If you say this diode will be ideal, that means they don't have a 0.7 volt. However, that is theory, cannot be applied. Okay? The thing is when the real diode, they both get the voltage of the diode for silicon diode, the voltage have to be 0.7.
Okay, so from what you're saying, it looks like on the two pictures on example 1 and 2, the bar on top of the triangle is on two different sides. Does that have any bearing on?
Now
the
that means the way they connect that doesn't
Okay.
matter.
Okay.
You can connect either go this way or go the other way, doesn't matter.
Okay.
Okay, now my
Wait,
question,
Professor, let me ask you this. If what you're saying is if I'm understanding, that means if your circuit only had 0.5 volts, that means the diode would never turn on?
for sure. That means if they let this 0.7, then the diode must be off. That's telling you this side have to be higher than this side, right?
Right.
Okay, so at least higher than 0.7, then they can let the current flow in.
So if that's the case on this example 1, that means it would be off, because if you do the calculations for the resistor to the voltage, the resistor is using 10 volts, if I did my calculations correctly.
Okay, now that's what I said right now. My question is, when you're looking into this circuitry, then you have to define diode, they be on or they will be off before you want to do anything. How do we know this diode on or off? Who
Because
knows?
the anode is more positive than the cathode.
Exactly the definition, right?
Correct.
This side higher than this side, okay? Then the diode will be on.
The cathode is at ground, which is 0,
Exactly.
and the anode is more positive. And anytime the anode is more positive than the cathode, then it's forward bias. If the anode is more negative than the cathode, then it's reverse bias.
Okay, correct. Now, in order to know the diode will be on or off, okay? First thing, I suppose no diode here. What VL equal?
ED 0.7. D.
That's what I said. If no diode at this connect here, what VL?
Would be 0.
No, it's 10 volts.
10 volts.
Yeah, 0.7 volt.
Oh, I'm sorry. You're measuring. Okay, sorry. I'm looking at it.
You
Okay,
have to calculate.
You see, you got the current I flow here, right?
Right.
Okay, if no diode here, that means they open here, right? If you don't
Right.
have a diode here, basically they open.
Oh, okay. So you're saying there's no wire there. It's open. Okay.
Then I will be 0, right?
Right.
Current cannot flow through the open circuit. So the voltage drop across our limit here. What that voltage drop? VR equal
I times R.
I
Three.
times R. And I
If I is
equals 0.
zero, then there's no drop.
VR equal I times R. I equals 0. So VR equals 0. So basically on this side you get 10 volts and they drop 0. So VL will be equal 10 volts, correct?
Mhm.
Yeah.
And now 10 volt one side, the other side will be round. That means 10 volt here higher than 0 here. So the diode will be on. Okay? What I'm telling you here, when working with the diode, if you don't know the diode on or off, you cannot do anything. Okay? In order to know the diode on or diode off, you suppose on the top, we have a no diode here, then what voltage on this side? If they higher than the other side, then the diode will be on. Okay, so on this example, the diode will be on. Okay, that is the first thing you must know. Second thing, the diode when they on, you cannot do anything, okay, in the circuit without substitute diode by the battery. Okay. Plus minus will be 0.7 volt. That means you get the battery plus minus 0.7. Okay. When the diode on, you substitute diode by the battery 0.7. So what VL be equal? What the VL will be equal? Who can telling me?
So you're saying you're substituting that for a 0.7 volt battery is what you're saying?
Yeah.
Well, would the V out then be 9.3? No?
No.
Okay.
If I say V out, if I
0.7.
give it to the meter to measure, you connect high side here, low side here, right?
Go with 2 here. Right.
Oh, you're talking there. Okay, sorry. I was thinking from the battery.
If you measure from here to here, what you voltage you get?
You can't see what you're writing.
I want the V out. Okay. I asking you, I giving you the meter. I asking you your car battery, how many volt? You have to using
0.7 B.
you have to using your meter connect high side to the red and the low side to the black. You're supposed to get 12 volt something, right? And now I check. You get the battery here. 0.7 volt. I asking you V out. That means the high side of the meter connect to here. load side connect to here. What you think you get the voltage?
0.7.
Exactly. 0.7.
That's what I got it.
So V out equal 0.7 volt. Okay. So now you can get they want the current I. Tell me what current I equal.
Voltage divided by resistance.
Yeah, you said I equal V. Right?
Right.
Okay, now you want to know V. Here. What that V equal?
Can V?
Huh. You get one side here, how many volt?
10.
This side, how many volt?
What's that?
1.0.
We already calculate V out equal 0.7, right?
The current is 10 minus 0.7 divided by 1K.
That's perfect. The voltage here. That means the difference between this voltage and this voltage. And this voltage we already calculate, telling you 0.7. So they will be 10 minus 0.7 divided 1K. Okay, that's what the calculate the current I.
Mhm.
And number 4, they want voltage across R. That means you take I times R. You already get I and R, so you can get the voltage across here.
Mr. Pham,
Yeah,
I'm like still on the Ohm's law stuff of lab volts. Like you just skipped, like, or you didn't skip, but you really went through the last half of the first packet and some of the second packet so fast. Like this is like irrelevant to where I'm at in the class. Like I'm just like I'm gonna take off and like just come and work on lab volts on
But-
Monday through Wednesday. This is impossible to follow you.
no. Basically, you have to understand first when you're working on the left volt.
Yeah, but you're so far ahead of where I'm at in lab volts. Like this is irrelevant. I haven't even gotten to like the voltage divider rule in the lab volts.
Yeah,
Like-
that's not the for at the time. However,
You're just like you're giving more information than it's possible to use or digest. Like this is useless. So I'll see you in class, but I can't follow this because I'm not even in there yet. So
no, don't worry about that.
yeah, this
I
is
said now,
terrible.
if you want to learn electronics, the basic thing you have to know. For example, if I know, you know that V equal I times R. Is that right? Ohm law.
Totally.
Or
I get that.
I
I'm there.
equal V divide R.
Yes.
Or R equal V divide I. That's an Ohm law. I don't care, you have to remember the formula. Okay?
Yeah,
When it said,
for you, this is like really obvious stuff, but a lot of people are they're not even in the second unit yet, and you're moving faster than the classes, as far as I'm concerned. So for whatever that's worth, I gotta sign out. It's just like just frustrating me.
Okay.
Yeah, I understand that, and I kind of wanted to echo the sentiment on the latter half of the first package that we were given on Ohm's law. You really kind of breeze through, and I'm not you know, saying anything negative here, but you really breeze through the parallel circuit and the shunt and all of that. And it would be really helpful for us. And I know, and maybe some have it really down, and maybe some could use some more instruction on that. But if you could go back to the characteristics of a parallel circuit and a shunt circuit and kind of write us out some examples, like take the time to go through it a little bit slower, and maybe do some board work that'll help us grasp the concepts better, so that we have that great foundation to move forward.
Okay. I understand.
Thank you.
Okay. So I try to review again. Okay. To make sure you understand the basic. And make sure, you know, we keep moving. So that's why, you know, try to be in the meeting. Okay. If anything do not quite understand, just go ahead. Okay. And ask it. I try to help you out. First thing they're talking about Ohm law. That means the relation between the applied voltage and current and resistor. Now, if you're looking into this circuitry here, okay, you get the power and resistor. So the power positive and negative. And also you can see you can get the current flowing. Okay. So the Ohm law means the relation between the voltage, the current, and resistor, and this is the formula. V or E, same thing, equal I times R. If you want I, you take the voltage divide to R. If you want R, you take the voltage divide to I. In this formula, E will be the applied voltage in volt. I will be the current in ampere, and R will be resistance in ohm. Okay? And now if they given you example, 6 volt here, and this is the resistor, and the current flow equal 25 milliamp. And they asking about what is the value of this resistor. So you're using R equal E divided to I. Okay, E equals 6 volt. I equal 25 milliamp. However, in this formula, I must be in ampere. Okay, they given you 25 milliamp. You have to convert it into ampere. So you take 25 times 10 power minus 3. That's what you get ampere. Okay? After calculation, you get R equal to 40 ohm. Any question, anything, just let me know. Okay?
This is all very straightforward. It's important to convert to the base units. Yes. Last lecture, you left off basically at the voltage divider rule based on my bookmark. So it might be a good idea to kind of review DC series circuit using the voltage divider rule and then move forward.
Yeah, we'll go through again. Okay? Okay, so basically any question about that thing? Okay, and this one just a formula. Okay, if you want to calculate the power, P equal V times I, and the P have to be in watt. So this is one of the formula. The other formula will be P equal I square times R. Okay, and the last one P equal V square over R. So basically, to calculate the power, you get three formulas. V times I square times R, or V square over R. Okay? In this formula, P will be in watt, V have to be in volt, I have to be in ampere. Now, we're talking about series circuit. Current is the same everywhere in the circuit. Okay? Total resistance equal to the sum of the individual resistance. The total voltage is equal to the sum of IR voltage drop across individual resistance. Total power is equal to the sum of the power dissipated by each resistance. That's just a summary for you. Now, if you're looking into this circuitry here, R1, R2, R3. Okay, so basically when you're looking circuit, then you recognize they will be series or parallel. Series, that means on resistor has the same current, only one current. You can see the current from here go to R1, go to R2, go to R3. So that's why you know R1, R2, R3 connect in series. Okay? So the first thing, if you want the circuitry only one resistor, then that's what they call total resistance. You add them up right here. R total equal R1 plus R2 plus R3 and plus Rn anymore. Add them up. Okay? And if you want to calculate the voltage,
Can I ask a question?
yeah,
What is that .RN? What does that exactly mean?
that means in this circuitry you get R1, R2, R3, right? Now you're adding one more, that means R4. You're adding another one, R5.
Oh, gotcha. Okay,
Okay.
thank you.
They're using Rn for any more. Okay,
Okay, thank you.
welcome. So if you want to calculate the voltage across R1, okay, that means from this side to this side, then you're using I times R1. Okay, very important thing for everyone. You have to remember. V R1. If you're looking here, VR1, that means the voltage across R1. Now, this side will be A, this side will be B. VR1 will be V from A to B, correct? Also, VAB always equal VA minus VB. Remember, okay? If I say VAB, you must be understand that means voltage from A to B, VA minus VB. And the same voltage VBC, that means VB minus VC or VR2. Okay, same thing, VR3 equal VCD, means VC minus VD. Okay, and everything here, they already calculate, okay? Number one, they want to get the total. Let's see, total resistance. Okay. Let's see, can I? This is an example for 2 volt, 24 volt. Okay, let's see. I try to see I can copy that.
Did you click paste image or just paste?
Paste.
Try paste image. Delete that. Right click.
No. Let's see.
No?
Copy again, okay?
Hmm. See, because you copied it down below here on that same slide. Maybe there's some kind of a lock on the. I don't
Okay,
know.
now I click copy, right?
It should copy.
Okay. Now if I go here, I want to paste them out. Paste, it. Okay.
There you go. Okay.
The thing is, last time I just paste.
Right.
How come I get two pictures? I don't
I
want.
think because you tried to do it before in the last lecture.
Ah,
Yeah, it's okay. Not a biggie. You can actually make that top picture bigger and it'll cover it up.
hey man.
You know how to do that? Oh, see, it's saving it on the same slide. There must be some kind of the way this was created.
Okay.
You could open a document, a Word document on your computer, share that screen and copy it again, and then open a Word document and you could paste it on the Word document. Or you could make an additional slide perhaps. I don't know how this PowerPoint was created, so it may have some.
Anyway, I will be learn more
Okay.
later. Okay. First thing, you see the circuitry theory. I want R total. And we know they will be R1. Okay. So they will be 2 adding 6. 8 for 12. Oh. Okay. And now I want to calculate the total current. E divide R total. Okay, they will be 24 divided 12. QM. Okay. Now, if they want to calculate the VR1,
12.
VR1 that means from A to B.
12.
Same thing. VA, B. Same thing. VA minus VB. And they will be equal Ohm law. I time R1. Okay, that means joule. Time joule. 4 volt. Okay, VR joule. Okay, will be equal I R joule. Same thing, VB minus VC. They will be joule ampere times 6.
And what we're doing here is we're figuring out what the voltage is across each resistor.
Exactly. That means I try to bring it up on calculation. Same thing, I R3. Joule times 4, 8 volt. Okay. If you want the power PR1, I square R1 I equal to square 4 times R1 to S1. Okay, and you can calculate the PR2 I square 4 times R 4 times 6 24. PR3 I square 4 times 4 60. Okay, the first one you get is what? Okay, so basically for the series circuitry, that's what we try to calculate everything. Okay. And now more questions regarding into voltage divider. So you can see this is a circuit. Okay, series circuitry. You can calculate the VR1 or VR2. Okay, like we already did it. You want to do calculate total resistance R1 plus R2. Okay, then you can calculate the current, take the voltage divide total resistance. However, now they bring it up for you one way. They say voltage divider. That means I want to calculate the voltage here. VR2. Normally, if you want to calculate the VR2, you need to get the current I, then time R2. Now they said we can using the voltage divider, okay, to calculate it. Voltage divider, that means you can get the VR2 will be equal, okay, E time R2 divide R1 plus R2. Instead, you have to calculate the current. And after you get the current, you multiply by R2. Then you can get the VR2. That's what they call voltage divider law. That can save you the time to calculate the current. And also now, if I want on the example, second one here, if you're looking on this circuitry here, second one, if I want VR3,
Can you use your pointer? I'm not sure where you pointed to.
okay,
Thank you.
I want let's see, VR4. Using the voltage divider, you want the voltage here.
Okay, right. Gotcha.
How can we apply voltage divider law? If you're not using the divider, Then you have to calculate the current. And after you get the current, you multiply by R4. Okay? Job can be done. However, what they said, they don't want.
Là nếu divided by that one, cái 50.
So what VR4 equal?
You want E times R4.
Okay, perfect.
Somebody's speaker's on.
Okay.
E times R4, right? Divide.
And then don't you add up the resistors?
Perfect. Okay. So, if I said I want VR3, first thing is time. Time what? Now I want VR3.
So it's times R3.
Perfect. Time R3. Divide.
1, 2, 3.
R1 plus R2 plus R3 plus R4.
So you have to include all of the resistors regardless of which one you're solving for.
Exactly. The thing is, VR3 will be I times R3. I mean E divide by the total. And now if I say I want VR1, will be equal to what? First thing you say, E time R1, correct?
Yeah.
And everything
Yes.
divided. That's what we call a voltage divider. If you don't want using voltage divider, first thing you have to take E divide by R1 plus R2 plus R3 plus R4. That means you get the current. Then you time R1. Okay? That to make sure guarantee if we're using the voltage divider. You know how. Only thing is using the voltage divider will be safer to you. You don't have to calculate the current. Okay? Now, for parallel circuit, in here they say voltage is the same across each branch of the circuit. Second thing, total current is equal to the sum of the individual branch current. Okay? The equivalent resistance are equivalent. Is less than the smallest branch resistance. Total power equal to the sum of the power dissipated by its resistance. Let's just summarize for you. Okay, and now you can see this is the way connect parallel. You get R1, R2, R3, or Rn. Okay, one side connect positive, the other side connect negative. The only thing is that you know the voltage across R1 or R2 or RON, they the same voltage. Okay, that means no different voltage. However, if you get a total current flowing here, when they get to this point, one going down, one go this way, okay, and so on. That means the total current will be equal I1 plus I2 or plus IN. Okay, everything they summarize here. Okay, and now I don't want this voltage, this circuitry. I want the circuitry this way. Only one resistor and one voltage. Okay, so that means you have to combine R1, R2, Rn, okay, into one resistor, we call R total. Two things you have to know. If you get more than two resistors, you have to use this formula. R total equal 1 over R1 plus 1 over R2 plus 1 over Rn. However, if you get only two resistors, you can use this formula. Easy. R total equal R1 times R2 divide R1 plus R2. If you want to calculate it, you have to get the formula. Okay? Now, in this one here, you get R1, R2, R3 parallel. They want the total resistance. Then you're using the formula 1 over R1 plus 1 over R2 plus 1 over R3. The calculate given you answer will be 3 ohm. Okay? If any question, just stop me, okay? And now you can get R1, R2, R3, R4. However, they want the total resistor from this point to this point. So the first thing I'm to look into that, I know R1 parallel R2. Then you can combine. You can get R5. So easy to calculate R5. R1 times R2. R1 plus R2. Okay? And now you can combine, okay? R3, R4. That I say R6. R6 equal R3 times R4 divide R3, R4. Okay? After you calculate R5, R6, and now R5 parallel R6. Then you can calculate RT equal R5 times R6. R5 plus R6.
And
Okay?
Mr. Sam,
Yeah.
I don't know about you. I think it's just easier to use that other formula where you go 1/R1, 1/R2, 1/R3, and put it in your calculator that way. To me, that's fast. I'm not saying that your way is, it just seems like it's,
Now, you said using the formula 1/1/R1, right?
right.
Okay. Depend on where they want our total.
Oh, I see what you're saying. You're picking a specific spot in the circuit where you want to know what R
Yeah.
total is.
They want to looking you from here to the circuitry.
All
Okay?
right.
That is the purpose they want the guy to know. Okay, if you're looking on the example here, they want the total from this side here to this side here. That only they telling you. Okay, this one and two parallel, you have to combine to get one. This R3, R4 combine to get another one. And this new and new here parallel. Then you can calculate the RT. Okay, and they already gave it to you, answer will be 50 ohm. Okay, and the last one here, R1 parallel R2. So the formula will be R1 times R2 divided R1 plus R2. Okay, last one. They're talking about current divider. Normally in a R1, R2 in parallel, and you get a total current coming in. Okay, if you want to calculate the current I1, then you're using the current divider law. That means you take the total current, okay, times R2 divide R1 plus R2. This is the formula. Okay, that's what we call a current divider law. And this one, they already get everything.
Be able to delete that.
Okay, now, what they want are total. R total, R1 only, R1, R2 parallel. Okay, then you're using the formula R1 times R2 divide R1 plus R2. You get 1.6 kilo ohm. Okay, now you want to calculate the total current. Then you take the voltage divide total resistance. Okay, and if you want to calculate the total power, P equal V times I, you know, you get three formula. P equal E times I, or P equal I square times R, or P equal V square over R. Okay, and if you come to calculate the IQ using the current divider law, okay, if you want to calculate the power R1 using E square divide R1, okay, power over R2 E square divide R2. So not cover not too much thing. Okay. And this one we already get to it. Okay. You can get any question or anything. That means basically for now, for DC.
Thank you so much for going over that.
Yeah, the thing is, we try to build up for you the basic fundamental.
Right.
Okay. If you can follow it, you can understand what we try to teach you. Okay. After you get through the program, go ahead, keep moving up. I guarantee you can get much better. That's what happened in this program. Okay. If you don't understand, just bring it up, asking. Or if you get a problem,
Thank you.
okay, then you can take to me. You want online, I help you out. Okay.
Okay.
Also, when you do your homework assignment, you not get it part, or you not quite understand something, take to me. I will be online with you, take you about 15 minutes to explain to you. Okay.
Okay. I appreciate that.
Yeah, no problem. That's what
Yeah.
I did. Okay.
Yeah.
Normally I will be on the class on Monday.
Okay.
Okay.
And you understand before I on the class 5 days, but now they not very much. Okay. Instead of my salary going up, they not going up. And also,
You work it out.
yeah.
You get it, Professor.
So I'm get older. However,
Yeah, you get it older too.
what I still like to help the people, the student want to learn to moving up in this area. Okay, then I have maximum. You can say in this program I get the Mr. Smith. He knows the thing. He been with me about 7 years. Thing is, he get older. He want to get interesting, try to learn more and more. Okay, no big deal. So what I said again, don't miss any handout. Don't miss any meeting. Okay, any question, anything I can help.
Yeah, I have a question. What is the next handout? I noticed you guys didn't print one out for us. So which is the next one that we should know that we should be studying next?
Okay, now let's see. I try to. Okay.
Okay.
Just a
Should
minute.
it be the diode one?
Yeah, that's what I said. Okay, just a minute. Just a 1 minute.
Oh yeah, it's on the it's on the Tech One handouts list.
Okay.
Okay. Diode rectification PDFs. Okay.
Okay. Now you need to download handout number 2, diode rectification. And also you download E01 report, the thing in next meeting. When we start, I will let your guy.
Okay.
take the quiz.
Not
Now,
bad.
now I can just try to show you, okay, how the lab will be, how the quiz will be next time, okay? So you know how to prepare that, okay? Let's see. Just a minute, okay? Now you can see, I just let you see quickly. Okay, you can see that the first one, number 1, 2, 3, and they will be giving you 3 minutes. Okay, and after
200,
you
32,000. Record.
can you see it?
Yeah.
Okay, so you can enter, you know, number 1, you select A or B or C or D. That's what you put it in your report. Okay,
See?
after you report it, then they done for the free, you can upload it. Okay, now suppose they take you 3 minutes to do it, and now
B, number 2.
I don't know. And now, okay, after that, after you get 2 minutes right now, okay, that one, they go through that one and we will stop it for today. That run for 20 minutes. Make sure when you try to do your assignment, you get a problem, okay? Just let me know. I will be help you out. You see that right now, 1 minute left. I just show you how we take the quiz, okay? That automatically, okay? After 3 minutes, automatically they go to the next question and they keep going until you
C,
get through.
B, A.
I don't know. But you get a 90 or over 90 to perfect. See that? Okay, so I stopped it now.
What general dynamics do you work for?
What general dynamic? Okay, before 1981 in Balboa. Okay, electronic division. And later on, they moved to the Rancho here. And they changed the name BAE system.
Oh.
Okay, but still general dynamic.
Yeah, BE assistant. I used to be assistant there.
Yeah, I get few people try to get into the the Zoom right now. That run out of time.
Better late than never.
Okay, make sure. I don't know how come you get in and they not showing here, so that's why I cannot click it. So maybe next time I have to do is try to not asking for the password. Okay, we'll see. I don't know.
So let me understand this correctly. The next Zoom that we have with you, which will be on Thursday, that's when we're going to be doing the quiz.
Right.
Okay.
When you start it, we get a 20-minute quiz.
Okay.
Oh
Then
wait,
then
wait,
then-
don't we have a Zoom tomorrow?
Yeah,
you
we
get
do,
a
but
no-
it's with the
It's
other
a
instructor.
time.
Yeah.
Okay. The Zoom tomorrow. Here, the lab instructor, he will be show you how to working on the circuit board, how to working on level. So that means Monday you coming, you start doing. Okay? Remember, concentrate on the level. I know who doing what. Okay? I'm looking into the server. Everything you're doing, they record in the server. Okay? If you can get through the assignment, quiz, and final test, and also the level, we not expect you 100%. Okay? Then you can get a certificate at the end of the sprint. Don't worry about the hour. If I'm not drop you out, then when you get into the end, you can get 450 hours, no matter what. That's a different the way before we did. However, I have to follow. So I don't worry about the hour. I just worry about what you learn from this program. Okay? So, any question before we stop it? Okay? If it's not, good night, everyone.
Good night. Enjoy
Good
your
night,
evening.
Professor.
Thank
Good
you
night.
so much.
Good night. Thank you. Bye-bye.
Bye-bye.
Yeah, thank you.